we're going to create our Terraform configuration, and it's for a particular environment where we're going to have two instances in AWS. One is going to be Windows Server 2019, and we're going to put Active Directory in it. And the other instance is going to be RHEL 9. And that's going to be our client machine. And what we're going to do is we're going to join the RHEL client machine into our Active Directory and be able to authenticate through it. And so we're going to create an environment for that lab through Terraform. And I'm going to demonstrate how I'm going to build how we're going to architect this. Okay, let's open up a PowerShell terminal. Throw these bash terminals. We're in desktop right now, so we're going to make a directory called Terraform. CD into Terraform. We're going to clear. Now we're going to use I'm going to use an IDE called Visual Studios, and I have an extension here with Terraform, and it allows me to assist me visually with like nice colors and stuff like that. That's the only reason why I like using an IDE. I'm gonna open folder and Terraform. There we go. Let me open up PowerShell first. Okay. PowerShell. Alright, so we're in Terraform directory, both in the PowerShell and in the IDE. And the first thing we're going to do is create a main file. And this is going to provide us, and this is not going to provide us. We're going to provide information about which provider we're going to be using. And provider basically is just which cloud platform you're going to use. And you have the option of GCP, Azure, or AWS. For in this instance, for this lab, we're going to be using AWS, right? The code base, you can just grab it from the Terraform docs, which is what I'm going to do here. What we want are these two code blocks first. We're going to paste that in. You have to use a region that's closest to you. The closer you are, the faster the speed will be. And you can look at which region you're closest to by just simply going to the AWS dashboard and clicking at the top right here. I'm closest to, well, I don't know. You can argue I'm closest to Ohio. To make things easier, I'm just going to put in US East 1. Okay. And otherwise adjust that accordingly. We don't need that comment. Going back to the docs, another thing that you're going to have to do is to input your access key and secret key. And this is what connects your Terraform with AWS. Now let's go ahead onto AWS and obtain said secret key and access key. And we're going to navigate through the IAM dashboard, click on user, and pick on the user that you're currently logged in with. you're going to go to the Security Credentials tab and then scroll down to Access Key. Here you'll find a button that says Create Access Key. You're going to want to click that, then click on Command Line Interface CLI. Then scroll down and check the confirmation that you understand the above recommendation and want to proceed to create an access key. Check that, click Next, create access key. You can skip the description tag for now, and you can add that later. Create access key. Here, what you're going to want to do is copy the access key, go back to your file, your Terraform file, and paste that inside the quotes. You're going to do the same thing with the secret key, and you're going to paste that in within the quotes. And by the time I publish this video, I will have already deleted these keys, so don't bother trying to hack me. And I recommend strongly, if you're doing something like this, do not show anyone your keys, please. Just a warning. Okay, we're done with that. Now we're gonna move on ahead, and we're gonna include our images that we want. And the two images that we're looking for is Windows Server 2019 and RHEL 9. I'm going to choose RHEL 9.7 because that's what I've been working on lately. And we're gonna target those images. But first, we're going to create an AMI file, Terraform, and let's first, there are a few things that we need to gather first. We need to look for the ownership ID, and, well, we need to look for the AMI ID first, and through the AMI ID, we're going to look for the ownership ID. The purpose of the owner ID is basically to see all the images available through that vendor. Could be Microsoft and AWS, which is what we're going to be looking for, and RHEL. And why we need an owner ID? It's because we want to know that the images are legitimate and not, suspicious from a third-party vendor. And we only want the official things, just to be on the safe side. Okay. So let's go ahead on to our AWS platform, and we're gonna click on we're gonna go to EC2. You can also go to the search bar and type in EC2, and you can navigate it through that way too. Let's scroll down and click on AMI catalog. And the first thing we're gonna filter out is first Windows Server 2019. Now each item that's listed below in your results, you're going to see the title and along with it the AMI ID. This is the AMI ID. And this is what I'm actually looking for. I'm looking for Microsoft Windows Server 2019 base. And along with that, I'm going to copy the AMI and put it into a text file. I'm going to create a text file in my Terraform directory called Notes, just to keep track of things, okay? So I'm going to paste that in, and this is the Windows Server 2019 base AMI. Next, we're going to look for RHEL. Looking for RHEL 9. Looks like our results. We only have one results that says RHEL 8. Let's try Red Hat. Let's see if that's... There we go. This is what I'm looking for. I'm looking for RHEL 9 HVM SSD volume type. This is the AMI ID. I'm going to go ahead and copy that and paste it into notes file run HVM. Okay. While utilizing the AMI ID, we're going to use this ID to find the owner ID. Now first, you're going to want to make sure that you have AWS CLI installed in your machine. So let's try that by looking at the version. Okay, looks good. And we're going to log in to connect this session to our AWS account. Go ahead and click on the account that you're currently logged in to AWS. And then after that, you can go ahead and close the tab. And here you can see that this signifies that you've successfully connected your account to the session. Okay. Now what we want to do is put in the command AWS EC2 describe images owners IDs, and we're gonna, sorry, not owners ID, getting way too ahead of myself, image IDs, and we're gonna copy this, paste that, and we're going to select the regions just to make sure that's it's available in that data center. Region East, select the region that you selected previously, and we're going to query and target the first item in the images array, and narrow that down with the properties that has owner ID in it. There you go. Clear. And this is our owner ID that we're looking for. We're going to copy that, and then we're going to save this below here. And for AMI, we're going to put in data. We're going to call it this code block AWS AMI when serve 2019. That's what we're going to call it. Most recent. We're gonna enable that. I'll explain in a second what that is. And our owner's ID has to be in square brackets and in quotes. So most recent basically means that there's gonna be multiple images to choose from. We're trying to automate this where we don't have to interact with choosing which image we want to choose. We want Terraform to choose for us. So if you have multiple images to select from in the catalog, then it's gonna pick the most recent version of it. So that makes our life easier. Now, from a list of there are multiple versions that RHEL is going to have, and we're going to try to narrow that down as much as possible by filtering through that list. Name and values equals. Now, let's go through all the RHEL instances available in this region within this vendor that has the owner ID of that. Okay, so we gotta do this. It's basically the same command. Except I'm gonna have owner's ID, copy, paste, and we want to display all the images and only show the properties with that has the image, ID, and the name. Okay, spelled that wrong. See it in a table. There we go. Okay. So we're looking for server 2019. Actually, this is exactly what we're looking for. But if you see the pattern, string patterns of all the others, we're going to include wildcards for the section of the string that is likely to change. So this usually can be, we can replace dates or version numbers with wildcards, so we won't have to be concerned about that. So I would say copy that. Paste. And the asterisk represents the wildcard. And that's, let's see if that narrows it down. Enough. What we can do is filter and then add name for name and values for that. I basically pasted this here. And that narrows it down. So from this, because we have most recent enabled, it's gonna pick the most recent one available. The very top. So 2026 third, this would be the most recent one. I'm satisfied with the length of this list, so I'm gonna copy paste it and have it in brackets within quotes. And the same thing is gonna happen for RHEL. For RHEL, we have an AMI of this. We're going to use the same command as we did for Windows. Okay, this is the owner ID. This is the official owner's ID. And we want to look at the table of images here. I particularly am looking for 9.7. A RHEL 9.7, and like the list is endless, and I'm not going through that. But looking at the pattern, the string pattern of all this, it looks like good for 9.7. This looks like a good base to choose from. I know I'm looking for an HVM, but let's filter out through that first. Okay. Close out of that, clear. I'm going to use a filter flag. Name equals name. Values equals RHEL. And don't forget the wildcard. 9.7. So I'm looking for that. Gonna add in this, and then a wildcard for this random number. I guess this represents the date 2026, January 20th. And I'm going to be using, and I want this architect, x86-64. Is that architect that I want? And then whatever comes afterwards. Let's copy that. Edit this. Oops. Paste that. There we go. I think that's good enough. The lists have been narrowed down, and I'm gonna paste this onto here. Okay, awesome. Now that's done. Let's go ahead and work on our instances. Instance is going to be for our 2 virtual machines that we're going to generate. Resource AWS underscore instance, and we're going to call it a Windows. What did I call it before? I'm going to call it the same thing, just to keep it consistent. And we're going to create one for RHEL too. What did I call it? RHEL. I'll call it RHEL 9. And I'll put 9 here too. Okay. So the AMI here, we can put the AMI ID, but that's not really necessary. We can just target this code block here rather than hard code it. And it's going to be data.aws AMI dot windsurf 2019 dot ID. And the same thing is going to happen for RHEL, except we're going to be using, you can pretend these things are like objects when you're accessing them or connecting them. That's the way I look at it. And instance type, I'm going to be using a t2.micro. We're going to cheap out on this. Same thing for RHEL. And if you want to look for other options that may be available to your liking, you can simply go to EC2 and then go to instance type. Now there are many to choose from, but usually I just look at the price here, how much it costs to run per hour, and I believe I picked T2 Micro. And as you can see, for Windows, when you're running T2 Micro, you're spending about 2 cents per hour, and for RHEL, you'll be spending about 3 cents per hour. We have to put in a key name. If I can spell name. Key name. And key name is something creates a key pair for you to connect to the instance. And this is the most important part. The name you give has to match the name that you create in the AWS dashboard. And we're going to call it a Terraform key. We're going to do the same for RHEL. And there we go. Now we're going to go ahead and create a VPC, which is Virtual Private Cloud. And this deals with our network, like IP addresses and subnets, stuff like that. One thing I did forget is that I want to add in a tag. And tags are just tags for instances are just the display name in the dashboard when you're looking at your instances, your list of instances. So when you open up, once this is created and you open up your EC2, you're gonna see Windows, one instance called Windows Server 2019, and the other called RHEL. Did I put 9.7? Yeah, 9.7. 9.7. Okay, now back to VPC. So, Virtual Private Cloud, what we're going to do is create a network for our environment, and within that network, we're going to create a subnetwork where our instances is going to live and communicate through. And then we're going to create a gateway that allows our machines to communicate with the outside world, to the internet. And the gateway is basically the bridge between our VPC and the public internet. And we're gonna also add routing and associations. We're gonna set it up where we define all IP addresses are gonna connect through the gateway to communicate with the internet. Association is just where we're going to link the subnet and our routing together. So let's go ahead and do that. So resource, AWS, VPC, and we're going to call it main. We're going to have a Cedar block. And enable DNS host names equals true. Enable DNS host names allows us to resolve using our public host names that AWS gives our instances. That's why later on, once we create our instances, you're gonna see the host name probably include something like EC2 or something that AWS will give it. So let's continue on. I'm gonna do shared subnets here. Resource AWS subnet, and this will allow us to link our instances together because they will both be within the same subnet. And we need the VPC ID. Cedar block to 0.0.0. 0.0. 0.0.0.0 source 24. So according to my subnet calculator, this is gonna give something like 65,000 IP addresses. So this subnet will provide 65,536 private IP addresses, ranging from 10.0.0.0 all the way through 10.0.255.255. And mistake here. And we're gonna create a subnetwork that's gonna live inside this network that has an availability. And we're gonna create a subnetwork inside this network that's gonna have 256 IP addresses, private IP addresses, ranging from 10.0.1.0 through 10.0.1.255. And we're gonna enable map public IP on launch to true. So this basically means that anytime an instance gets created within this network, that instance is automatically going to be assigned a public IP address. So that's what this does. And now we're going to create the internet gateway. That's going to be the bridge between our VPC and the public internet. Gateway. And we're going to call it I for internet, GW for gateway. Oops. GW for gateway. Okay. And we're going to do the same. We're going to get the VPC ID. And we're going to create the route table. Resource AWS the VPC ID for this, and then we're going to create the routing, the route here, Cedar block, and we're going to apply this to all IP addresses. The gateway ID, I'm going to link this to the gateway ID here. ID. Okay. We're basically saying that all IP addresses within our VPC has to go through our gateway if they want to access the internet. That's basically what it's saying here. Finally, we're going to include associations. US route table associations. We're going to say R for route, T for table, A for associations. And we're going to link the subnet and our routing table together. Subnet ID. ID. And our route table ID. And that's it. These two are going to be associated together. It's basically what it is. Routing table, shared subnet, and our routing table. So basically, everything inside the virtual private cloud, everything inside this network is going to be routed to the internet gateway, including the subnet, which is everything, all the instances in this network, is going to also route through the internet gateway. I hope that makes sense. Next, we're going to create security rules. All right. So we're going to name it security. And we have to create a security group first. And this will encapsulate everything that we want to change in terms of inbound and outbound traffic within our network, within our VPC. So resource, AWS, security group. We'll call it allow all because I'm just going to open up all the ports and protocols for the sake of this lab of going smoothly. So allow all traffic. That's what we'll label it as. The VPC ID you can get here. Make sure we can just copy it here. created a group just to be organized. And now we're going to create inbound rules. Resource AWS VP VPC security ingress rule. And then allow IP v4. I need the security group ID. I'm gonna associate that. Security group ID equals that. And Cedar block, similar to the subnets. We're going to apply this to all IP addresses, all IPv4 addresses. So it'll be 0.0.0/0. So all IP address will open ports and protocols -1 being open to everything. Allow all traffic. And we're going to do the same thing for egress, outbound rules. And that's it. And what we want to do, we want to implement this to our instances as well. Almost forgot that. So it can all communicate with each other across files. We'll just append it here. VPC security group IDs .id. Same thing is going to happen for RHEL. Roll out all protocols to be open. And the subnets, I'm just realizing it here now. I don't have subnets. That's gonna let AWS know that this has to be within the same network. So VPC need to grab the ID here, attach it to our instances. I'm gonna put it above the security. Same thing goes for RHEL. Okay, I believe I'm done here. I'm gonna go ahead and build this infrastructure, Terraform init. I'm gonna initialize Terraform. Let's see what's going on here. Can I retrieve the list of available AWS VPC providers. Providers. AWS VPC. Okay, I think I know why. Yeah, underscore that. Let's try it again. Oops. Terraform in it. Okay, so it's initialized now. Terraform form plan. Show me the plan. Okay. Okay, I can see that I have been hyphenating. I hyphenated this in the security file, line 3. Okay, there has to be an underscore. For this, in security file number 6, allow port, resource. What's the problem with this? Let's support resource type. And resource, I don't know. No. Line 6. Okay. Looks like I hyphenated a lot of things. So I'm gonna fix that first. So this VPC file line 7. I also hyphenated VPC line 13. Okay. Let's hold up. Let's clear everything so I don't get confused. AWS owners group. Oh, security group. Okay, security group. Clear. I also have VPC line 17. Underscore. Clear. Terraform plan. On my AMI line 11. Incorrect attribute. Instance line 6. Right, because I have to put. Oh, okay. AW. Hold up. Okay. This has to be in square brackets. As you can see here, when you're making configurations, this is for the egress. Here we go. When you're in the instance section, you have to make sure that it's encapsulated with square brackets for your security group ID. So that was So that was the error. Clear. Let's try that. Let's plan again. Let's see what happens. Edge of my seat. Career return, please change the criteria. AMI. Okay, your career returned no result. Please change your search criteria and try again. Okay, let's see here. So we created an AMI. The AMI. Oh, okay. I see what's wrong here. I'm using the same owner ID. Okay, let's change that. Yeah, sometimes it's good to backtrack. What I was looking for is I created a provider, then from the after the provider I would create the image. So I was going step by step in each file that connects to each other. Okay, clear. It should work now. Okay, it looks good. Now let's Terraform. Apply. Let me just check. I had some instances here before. I think it cleared out. Yeah, I have no instances, as you can see. Excuse me. Now we're gonna apply it and to skip the interactive stuff. We're gonna put auto proof. It should work now. Oh, you know what? I don't think I created the key pairs. I don't remember. What does this say? Yeah, invalid key pairs. Right. Completely forgot about that. Key pairs. It's going to be in an instance. Yeah, as I said before, it has to be the same exact name, so I'm going to copy paste this so I don't make any mistakes. Preferably copy paste this thing. We're going to go to key pairs here. Create key pair. Has to be the same name. Leave it at RSA and PEM file. It should download. This is my key pair here. And okay. Now it should work. Apply and approve. Should work now. Come on. Come on. Come on. I don't think there's anything outstanding. It should work. It should build everything now. See, created a Terraform backup here. Okay, it looks good. Awesome. I cannot not smile right now. So the instances are being created here. As you can see, they're both in the same subnet, and just gotta wait for the status checks, and then we're gonna try to connect to each instances, see if everything is working properly. Okay, it looks like checks have all passed. Let's go ahead and connect to our RHEL machine. Gonna connect through SSH. If now I'm this physical machine that I'm on right now is a Windows machine, but if it was a Linux machine, you would have to change the file permission. 400 just means that to make it available to read through your machine. But since this is Windows, we'll go ahead and copy that. Let's clear this. Actually, you want to make sure you are inside the same directory as the PEM file, which is likely my download folder. I'm going to cd into download. And then we're going to paste an SSH into that. Click yes. Alright. So we're currently inside of the RHEL Linux machine. This is the private IP address 10.0.197. That's correct. Hostname. Oh, the hostname is right there. Alright, now let's also check our operating system. What operating system we're in. Let's get that out. And oh man. Red Hat release. As you can see, Enterprise Linux 9.7. So we're good on that end. Now let's connect to our Windows Server machine. First, before we can go ahead and download this. We're going to need that later. But first we have to get the password to log in to our local account in that machine. And we're going to upload the PEM file that was downloaded. And decrypt password. And here you got the password and you got the username. So open up the RDP. You want to make sure this is checked and connect. And here you just want a normal user that's being provided here. And we're going to paste the password here and click remember. Then this window opens up and you're going to click yes. Make sure you check that box too. And you will get this window. Okay, here we go. Here's a server manager. Let's go to settings. You can click yes. Go system, and then we're going to go to the about. See what operating system this is running. It's Windows Server 2019 Data Center. And there you have it.